This is a hypothesis test about the population mean, mu, and we will be using the traditional method. During a recent year, the average cost of making a movie was $54.8 million. This year, a random sample of 15 action movies had an average of $62.3 million, with a standard deviation of 9.5. At alpha 0.05, can it be concluded that it costs more than average to make an action movie? So we see that we have here a standard deviation, and it appears that the standard deviation is a sample standard deviation based on these 15 movies. And so because it's a sample standard deviation, we will be using the t-table rather than the z-table. The z-table is used when you know the population standard deviation. The level of significance is 0.05 that we'll be testing it at. And they're asking whether it costs more than the average to make an action movie. So when we set up our hypotheses here, the equal sign always goes in the null, and then it appears that they're claiming that it costs more than this to make an action movie. So we're going to put our claim with the greater than sign, the more than. Then the next step, where it asks you to find your critical values, this is going to be a right-tailed test because of the greater than sign, so there'll just be one critical value, and we'll find it from the t-table. On the t-table, in the left-hand column, the degrees of freedom are one less than the sample size, and our sample size is 15, and so the degrees of freedom are 14. So we're reading on this line. The alpha that we're going to use is 0.05, and we're going to be reading on the line for a one-tailed test. This is a right-tailed test. Here's our alpha. We'll come down to line 14, 1.761. That's a right-tailed test, so the 1.761 is positive. And there's one critical value, one critical region, on the right side. One critical value, one critical region. Now we're going to calculate the test value. It will be a t-value, and it will be calculated by taking the sample right here, the 62.3, and subtracting away the hypothesized mean. You put that over the sample standard deviation, which is this 9.5, over the square root of the sample size, which is the 15. When you put that in your calculator, you get a 3.058. That's clearly over here in the critical region. It's a lot larger than the critical value. And so when we make our decision in step 4, we are going to make the decision to reject the null hypothesis. Because the test value is in the critical region. So we're rejecting the null hypothesis. And when we come back up here and we reject this null hypothesis, we're saying that the alternative is true, and the claim has been attached to the alternative, so we're supporting the claim. I'll say it one more time. We're rejecting the null, which means the alternative is correct, and the claim is attached to the alternative, so we're actually supporting the claim. So you say there is enough evidence to support the claim that action movies cost more than other movies.